project with a speed u at an angle theta. This everything is a ground, will write it. How the trajectory of the ball will be. So the ball will move in a parabolic path. Again, it will strike the ground at some distance. Then, so what is this particular path? This will be the path of trajectory. So how the trajectory will move? It is going to move in a parabolic path. This particular thing is called as parabolic. Why parabolic path? All we are going to create suitable proof. Agreed. This one. Then here, when ball is projecting, what are the quantities that will be acting? So when you project a ball with a speed u, the weight mg will act. So how do I expect it to move? So it's going to move in a resultant path. What is this? This red color one is a path. So how the ball? The ball will be moving in this parabolic path. It will not move along the projected velocity. Get this one? So how do it move? The ball will move in a curved path. Why do it will be a curved path? Because under action of the weight, because of the velocity and the weight, the resultant path will be in this direction. Some curved path, let it be that one. So now, what about assumptions we are making? We are assuming that there is no acceleration along x-axis. And what about acceleration along y-axis? G. Why there is no acceleration? Because how the weight of the body will act. The weight of the body will act vertically down. So therefore, this weight, so how do we write here? Ay is equal to mg by m. So we will provide acceleration along y-axis, the weight. Get understand? So because of the velocity projected and because of the gravity acting, the resultant path will be some curved path. This will be that one. Okay, there's a one basic idea. So why do it move in a curved path? There's a one basic background. So one must know that this information. This is something very important. Why it will move in a curved path? Okay, let's see that there's a why there is no acceleration along x-axis. Because how the weight will act? The weight will act vertically down. So naturally, there won't be any acceleration along x-axis. Getting this idea? No. We'll apply what is all this projectile motion. Projectile motion is all about the applying the equations of motion along x and along y. Along x and along y, we'll apply the equations of motion. That's what all the entire the projectile motion. So after some time, where the ball will be. So the ball will arrive here. Let me put a dot, like this is a ball projected from the ground. After some time, it will have horizontal component and vertical component, and it will definitely will ascend some height. Let me call y, and it will be at a horizontal distance x. At t equals 0, we have projected. At any time t, let it be here. And here it will have the velocity v. How the velocity v will be directed tangential to the path. And after some time, it will ascend to the highest point. So what about this? This particular thing, we'll call this as a highest point here. The ball will move in a curved path here. Call this is V2. Here V3. V4. V5. And finally, it will strike the ground with the same speed. Okay, this is about the path what we have to trace it out. Then let's come for one by one. Few quantities like this particular thing is called like a range. The maximum horizontal distance covered by the ball in the curved path. is called like a range. So this will call this as a range, that one. So this is called as a range. Then afterwards, it is going to ascend a maximum height. Here, this one. It is going to ascend a maximum height in this entire trajectory. When it moves in this curved path, it is going to ascend at a maximum height. This will be maximum height. This particular thing, what we'll call this as like a maximum height ascended. H will call it. Then this distance will be r by 2. Then it will come back and it will come and strike the ground again after some time. Say at t equals 0, I projected. So it will move in a curved path. After some time, again it will come and strike the ground. So this particular thing will become time of flight. After what time, again it will return back to the ground. So that particular thing, we'll call that as a time of flight here. So now we'll define all the quantities one by one. This is very important. Let me keep it here. Now let's write all the possible equations along x-axis. Equations of motion. So then what we can write? X equal to u cos theta t. I'll write this ux t plus ax t square by 2. What is ux? What is x? What is u? Initial speed of projection. So what is this u? This is the initial speed of projection. What is this theta? Angle of projection. We'll define like this. Then what is the initial velocity along x-axis? The initial velocity along x-axis, we write it as u cos theta. Initial velocity along y-axis is u sin theta. Acceleration along x-axis is 0. Initial velocity along x-axis u cos theta. Let me substitute all those things here. Fine. After substituting that, we'll get this is u cos theta plus 0 t square by 2. This everything will become u cos theta into t. So this will give the one horizontal position of the particle. This is something very important. X equal to, I'll write down one. X equal to u cos theta t. So this will give the horizontal displacement of projectile or a ball at an instant of time t. This is called like a path or trajectory. The ball is called as a projectile. We are giving one specific name. It can be any object. The particular ball is called as a projectile, that one. And the path traced by the projectile is called as a trajectory of projectile. Then along y-axis, we'll apply the equations of motion. So what was the velocity along y-axis, initial velocity along y-axis? We'll resolve here. U cos theta, u sin theta. You have to make observation here. Okay, fine. So what is the initial velocity along y-axis? It is u sin theta. At t equals 0, u sin theta. After some time, because of the retardation by the gravity. So what do you expect? How do this g is acting opposite to u sin theta? So what do you expect now? The particle initially will undergo retardation. So therefore, along y-axis, we'll write the equation. Along y-axis, y equal to uy t plus ay t square. Now substituting all the values, uy, u sin theta t, ay will be g, y negative sign. Why this particular negative sign for g? Look at this G, how it is acting. This AY is acting opposite to initial velocity u sin theta. And according to the convention, what we do, whenever acceleration is directed opposite to initial velocity, it should be taken negative. Okay, agree this? So there's one basic idea of why negative sign. So this is about the, now we'll substitute this, this another equation we have. We'll substitute equation 1 in 2. One in 2. Then this will be u sine theta x by u cos theta minus g by 2. P square will be x by u cos theta whole square. So this will be x tan theta minus gx square 2u square cos square theta. Now the equation what we had, this is the equation of the trajectory, what we can call it. So what is the name we'll give it? Equation of trajectory, or like a mathematical equation which will determine the path of the trajectory. It will move in a path. So how do this equation represents like a parabola, y equal to alpha x minus beta x square. So this equation of trajectory represents a parabolic equation. So therefore, what is the path of trajectory? Parabolic path. So therefore, for the projectile motion, what will be the path? The path will be a parabolic, this particular path. So how do the ball will move in a parabolic path. So this will be a parabolic path. The trajectory will be a parabolic. Like this is what we are giving a proof for.